Hi everyone, my name is Yuezhong Li. I'm from Ocean University of China. The topic of my work is invisible backdoor attack with sample-specific triggers. My co-authors are Yiming Li, Baoyuan Wu, Rongkang Li, Ran He, and Sui Li. I will first introduce the background of this work. As we know, a DNA model cannot be used without training and the testing process. Nowadays, many works investigate the security problem targeting these two processes. One category is to develop adversarial attack, which is applied in the training process and confuse the DNA to output a wrong label. Another one targets for training process, which is called backdoor attack. In this attack, training samples are pointed by inserting specific patterns on images, such as a black block at the red bottom corner. After training, the DNA model can perform well on clean samples but bad on poisoned samples. In recent years, many works for backdoor attack are proposed, and we can divide them into several categories. The first is visible backdoor attack and sample agnostic, as we can notice the trigger and the trigger is fixed. The second is called invisible backdoor attack and sample agnostic. For example, this work had an imperceptible perturbation to images. The third one is visible backdoor attack and sample specific. The trigger is different on different images, but can lead DNA to output the same target label. But so far, the fourth category, invisible backdoor attack and sample specific, is not well studied. So in this work, we propose sample specific backdoor attack. Compared to previous work, our method can create invisible and sample specific triggers. Since the most existing defense methods are based on the assumptions that the triggers are fixed or agnostic, our method can bypass these defenses in nature. Here's the pipeline of our attack. In attack stage, we develop an encoder-decoder structure to generate triggers and inject them to the training set. In training stage, users adopt the pointing training set to train DNAs with the standard training process. In inference stage, infected classifiers will behave normally on the benign testing samples, but predict incorrectly if the trigger is added. To generate sample-specific triggers, we use an encoder-decoder network as an example to generate sample-specific triggers, motivated by the DNA-based image seismography. Firstly, the string is concatenated with the benign image. The encoder aims to embed the triggered image, and the decoder can recover the string. Theoretically, the trigger can be target label or other strings. Here's the attack experiments. The figure shows our method is more imperceptible. We also report attack performance of our method, which reveals our method is on par with others. Our method is tested on the following defense methods. We can see our methods retains attack ability with neuron pruned, and the neural gleans hardly synthesize the pattern of our method. The SANInet cannot locate the trigger properly. For strict methods, our method achieved the highest entropy score than others. We also show the performance of our method resistance to these defense methods, which demonstrates the effectiveness of our method. Thanks for listening.